Okay, so continuing with our derivation, we just got n1 cos theta r equals n2, or cos theta r equals n2 by n1. This is what we just derived. Now we also had this equation n0 sin theta a equals n1 sin theta r. Now we have an expression for cos theta r, but what we actually need is sin theta r. So now we bring back our very famous relation between sin and cos. Sin square theta r plus cos square theta r equals 1. So from that you get sin theta r equals root of 1 minus cos square theta r, which is root of 1 minus n2 by n1 whole square. So when you take the LCM and simplify, you will get sin theta r equals root of n1 squared minus n2 squared upon n1. Now you take this, this is the value of sin theta r. You put it back in this equation. n0 sin theta a equals n1 into root of n1 square minus n2 squared by n1. So the n1 and n1 gets cancelled. This is the final equation you get. n0 sin theta a equals root of n1 squared minus n2 squared. And generally n0 is the refractive index of the external medium, and unless the question explicitly states something, we assume that the external medium is always air. So we take n0 equals 1. So sin theta a equals root of n1 squared minus n2 squared. This is the formula. So what is this? Theta a again is the maximum angle of incidence at which you can shine light, so that you do not lose any information. And the expression for that is root of n1 squared minus n2 squared, where n1 and n2 are the refractive indices of your core and cladding respectively. Now theta a is your acceptance angle and sin theta a is your numerical aperture. So what did we just do? We derived the expression for numerical aperture or acceptance angle. So quick recap, we just applied Snell's law 2 times. Once here n0 sin theta a equals n1 sin theta r, and then once at the core cladding boundary, n1 sin theta c equals n2 sin 90 degrees. So sin 90 degree is 1, so we just left it as n2, and sin theta c is the same as cos theta r, so we replace sin theta c with cos theta r. How did we get this? Because these two angles add up to 90 degrees. So from this we got an expression for cos theta r. Using that and sin square plus cos square equal to 1 identity, we got an expression for sin theta r, which we simplified and plugged back into this equation. We got this expression finally, and n0 we generally assume to be 1, so we get the formula for sin theta a to be root of n1 squared minus n2 squared. That is the derivation for numerical aperture.